everyone, welcome back to the channel where we break down maths topics the easy way. Alright, a few of my lovely viewers watched the last video on set notation and wanted to know some of the applications of set notation. Today we're going to see those sets in action using something called a Venn diagram. Think of this as part 2 of the story. A quick recap, in the last video we talked about sets, intersections, unions, but these were just symbols and curly brackets. Venn diagrams are how we draw them so we can see exactly what's going on. So what's a Venn diagram? A Venn diagram is just a rectangle, which is our universal set, with circles inside. Each circle represents a set, so you might have one for set A and another for set B. If the circles overlap, that's showing you the elements are in both sets. Now let's understand the regions of a Venn diagram and connect some symbols to pictures. The first we're going to look at is the intersection, A intersection B, which is the part where the circles overlap. It shows elements that are in both A and B, as shown by the shaded region on the diagram. The next is the union, A union B. This means that we're looking at everything that's in A or B or both, as in all of the shaded regions inside both circles. Finally, we've got the complement, A complement. This means everything that's not in A, so anything that's in B but not in A, and anything that's not in either of the sets. A great way of picturing all three is by shading the relevant region so that you can clearly visualize what's happening. Now, let's use this information to calculate some probabilities from a Venn diagram. Let's say in set A, we've got 5 elements. In the intersection, there are only 2, and in total across the whole diagram, we have 11 elements. As 5 are in set A, the probability of event A occurring, as in choosing one of the numbers in the set, is 5 out of a total 11 possible elements. Now the probability of being in the intersect, so probability of A and B happening, is 2 because we've got 2 elements out of a possible 11 again, because we're considering the whole set. And now let's combine 2 of our known symbols and have the probability that we're not in A, but we are in B. And to do this, let's do a quick shading of the diagram to see what we're involved, because it's a bit harder to visualize. So not in A would be all the stuff in red, the outside bits, I'm just doing a rough sketch, and all of the tiny bits inside B. And the elements in B would be all the stuff in yellow. The region we're interested in is the overlap of both colours, so the yellow and the red bit. This means that out of a possible 11, the probability of being not in A and B is 5, as there are 5 elements in the overlap. Now, there's another bit called conditional probability, which is the tricky bit. Sometimes the question limits you to just one set, which we call conditional probability. For example, what is the probability of being in B given you're already in A? This means that at the start we only consider set A, which I'm going to mark in red. Rather than considering all 11 elements, we are just considering the 5 elements in A. We want the probability that we are in B given, which is this little straight line symbol here, given we are in A, which is basically the probability of B and A divided by the probability of A, because we want the parts of B that are already in A out of the possible parts of A. We calculated before the probability of B and A, which is the probability of A and B, is 2 out of 11, and the probability of A is 5 out of 11. which means the probability of B given A is 2 out of 5. Another way of looking at this is just by using our diagram and seeing there are 2 elements in the overlap out of a possible 5 elements of A, because the overlap only contains the element 2 and 5. So looking at the Venn diagram and using previous facts, we can calculate conditional probabilities. Similarly, the formula for the probability of A given we're in B is the probability of A and B divided by the probability of B. And this is a good little formula to note when calculating conditional probabilities. And there we have it. Now, when you see A intersect B or A union B, you won't just be imagining curly brackets of a set. You'll see the bigger picture. If you haven't seen part 1 yet, the set notation video, check it out so all of this makes even more sense. And as always, like the video if this helped, subscribe for more Maths Made Easy, and drop a comment if you'd like any other content explained. You've got this. See you in the next video.